Today I am going to talk about magnetic particle inspection. Magnetic particle inspection is governed by the laws of magnetism and is therefore restricted to the inspection of materials that can support magnetic flux lines. Materials are generally classified as ferromagnetic, paramagnetic, and diamagnetic. Ferromagnetic materials are those that are strongly attracted to a magnet and can become easily magnetized. Examples are iron, nickel, and cobalt. Paramagnetic materials are those that are weakly attracted by magnetic force of attraction. Diamagnetic materials are those slightly repelled by a magnet and cannot be magnetized. Magnetic particle inspection is a non-destructive testing method used for defect detection. Magnetic particle inspection is fast and relatively easy to apply, and part surface preparation is not as critical as it is for some other non-destructive testing methods. These characteristics makes magnetic particle inspection one of the most widely utilized non-destructive testing methods. The method is used to inspect a variety of products from including casting, forging and weldments. Many different industries use magnetic particle inspection for determining a component's fitness for use. Some examples of industries that use magnetic particle inspections are the structural steel, automotive, petrochemical, power generation and aerospace industries. Underwater inspection is another area where magnetic particle inspection may be used to test items such as offshore structures and underwater pipelines. Principles of magnetic particle inspection. In theory, magnetic particle inspection is a relatively simple concept. It can be considered as a combination of two non-destructive testing methods, magnetic flux linkage testing and visual testing. When a bar magnet is broken in the center of its length, two complete bar magnets with magnetic poles on each ends of each piece will result. If the magnet is just cracked but not broken completely in two, a north and south pole will form at each edge of the crack. The magnetic field exits the north pole and re-enters at the south pole. When the field spreads out, it appears to leak out the materials and thus is called a flux leakage field. If iron particles are sprinkled on a cracked magnet, the particles will be attracted to the cluster not only at the poles at the end of the magnet but also at the poles at the edges of the crack. This cluster of particles is much easier to see than the actual crack, and this is the basis for magnetic particle inspection. This is the example of magnetic particle inspection using yoke. This device is known as yoke. The yoke will provide the magnetism, and we use blowers to blow the unwanted magnetic particles. These are other examples. We use magnetic powders in different colors for different occasions, and we will get results like this. This is yoke. Yoke is used for making the material magnetic. This is the result of a service induced crack in a crane hook with fluorescent wet particle methods. Here we can see the crack clearly. This is the crack. This is the crack we can see from the magnetic particle inspection method. We are using fluorescent magnetic particles here, so that's why it is this much efficient and visible. This is another example from a gear. Here we can see the crack clearly. This is the crack. Advantage of magnetic particle inspection is it is quick and relatively uncomplicated. It gives immediate indications of defects. It shows surface and near surface defects, and these are the most serious ones as they concentrate stresses. The methods can be adopted for site or workshop use. It is inexpensive compared to the radiography. Large or small objects can be examined. Elaborate pre-cleaning is not necessary. These are the advantages of magnetic particle inspection. There are some disadvantages also. It is restricted to ferromagnetic materials, usually iron and steel, and cannot be used on alternate stainless steel. It is messy. Most of the methods needs to supply of electricity. It is sometimes unclear whether the magnetic field is sufficiently strong to give good indications. The methods cannot be used if a thick paint coating is present. Spurious or non-relevant indications are probable, and thus interpretations is a skilled task. Some of the paints and the particle suspension fluids can give a fume or fire problem, particularly in confined spaces. So this is about magnetic particle inspection. Thank you.